Today I am going to discuss about the Markov process and the Markov chain. Let me start with Markov chain process. The Markov process is one in which the future value is independent of the past value given the present value. So the process in which the future value is independent of the past value, but it depends upon the present value. Okay, so that is called Markov process. Then what is Markov chain? Markov chain, if for all n probability xn equal to an given xn minus 1 equal to an minus 1, xn minus 2 equal to an minus 2, and so on. So here you can say here capital X and so on. So x0 equal to a0, and here you see this is a conditional probability of xn equal to xn. If we want to know about this probability, then we have again n minus 1 options. Out of the n minus 1 options, we can say it depends upon only the present value xn minus 1. In order to determine xn equal to n, we will depend upon xn minus 1, not xn minus 2, not xn minus 3, not x0. Okay, so we can write it as probability xn equal to an given xn minus 1 equal to an minus 1. So this statement is equivalent to saying probability xn equal to an given xn minus 1 equal to an minus 1. So it depends upon only present value, not the past values. Okay, so in order to determine xn, I consider xn minus 1 my present value, and I can determine the future value xn. So xn equal to an does not depend upon any other value except sn minus 1. So this type process is called Markov chain. Then this process is called Markov chain. Although we are having n minus 1 states, but the future state xn depends upon only one state xn minus 1. Depending upon xn minus 1, we can able to determine the future state xn. So xn minus 1 is my present state and xn will be my future state. It is denoted by it is denoted by bracketed xn for n equal to 0, 1, 2 and so on. So is called Markov chain. Here you see that this A1, A2, A0, A1, A2, An are nothing but states. Are nothing but states. So here you can see here A0, A1 and so on so An and are called the states of Markov chain. That means here I can say an minus 1 means state n minus 1. Here an means state n. So n minus 1 will be my present state and n will be my future state. N minus 1 to n. So an minus 1 to an. An minus 1 to an. So these constants a0, a1, an are called states of the Markov chain. So the conditional probability, so here we can precisely write it as the conditional probability we can write in this way, probability xn equal to aj given xn minus 1 equal to ai. That means state ai to state aj is called the one step transition because n minus 1 to n, so is called one step transition, one step transition probability from state ai to aj. So ai is my present state, aj will be my future state at nth trial. At nth trial, in nth trial, if I have the probability, conditional probability xn equal to aj given xn minus 1 equal to ai, that means one step transition probability from the step ai to aj in n trial, in n trial, and it is denoted by we can write here pij. Here ij, you know, it is related to matrix. I means the row, j means column. Since we are finding the transition probability from state ai to aj, so we denote it as pij, and our number of trial is n trials, so n minus 1 to n. Okay, so this is the notation of probability xn equal to aj given xn minus 1 ai. Probability, this is one step transition probability from state ai to aj, state ai to state aj in n trial, in n trial. Okay, so here I want to give another important definition under which condition this Markov chain will be homogeneous. So here I said that this is in the nth trial. Okay, so this is the one-step transition probability in nth trial. Now, depending upon this, I can define homogeneous Markov chain. Homogeneous Markov chain. If the one-step transition probability, if the one-step transition probability, if the one-step transition probability does not depend on step, does not depend on step. That is, I can have here step n minus 1 to n or step m minus 1 to m. Still the transition, one step transition probability. Remember, one step transition probability should not depend. That will be independent of the steps. Then we can say that is homogeneous Markov chain. That is Pij n minus 1 to n is equal in n try. The probability, one step transition probability from state ai to aj in n trial is equal to the one step transition probability to state ai to aj in m step. If it does not depend upon the step, then we say the Markov chain is homogeneous Markov chain or stationary Markov chain. If the one-step transition method does not depend upon the step, that is Pij n minus 1 to n, Pij m minus 1 to n, the one-step transition probability in n step is equal to the one-step transition probability in m trial are equal, then we can say it is called then the Markov chain is called homogeneous Markov chain or stationary transition probability. Stationary transition probability. Okay. So here I would like to tell you one thing. You remember that I would like to tell one thing. When the Markov chain is homogeneous, the one-step transition probability will be simply denoted as Pij. If the Markov chain is homogeneous, then we denote it as Pij. We denote it as Pij, and the corresponding matrix P. Capital P is the matrix corresponding to the one-step transition probability, where small pi are the elements of the matrix capital P is called one step transition probability matrix. And it is in short form you can say TPM. Okay, so this is the transition to one step transition probability matrix. We denote it by capital P, and this happens when it is homogeneous Markov chain. When it is homogeneous Markov chain. So now my question is how to construct the TPM. How to construct the TPM, which I will discuss in my next class.